recall that in the absence of a ligand, G protein-coupled receptors, GPCRs, remain coupled to and bound with an inactive G protein, which is GDP bound. G protein-coupled receptor, GPCR, signal transduction begins with binding of a ligand at the extracellular surface receptor, resulting in the formation of a GPCR ligand complex. The formation of a GPCR ligand complex causes a conformational change in the coupled G protein. The conformational change in the G protein causes it to dissociate from GDP and instead bind to the more energy-rich GTP, which activates the G protein. Next, the activated G protein dissociates from the receptor and diffuses along the intracellular side of the membrane and becomes associated with an inactive membrane-bound enzyme. The association between the GTP-bound G protein and the enzyme facilitates the phosphorylation of the enzyme, in which a single phosphate group is removed from GTP, transforming it to GDP. The phosphorylation of the enzyme provides it with the energy input that activates it and allows it to facilitate a subsequent enzyme-mediated cellular response. Following the enzyme-mediated cellular response, the activated enzyme is dephosphorylated and subsequently inactivated. The GDP-bound G protein once again becomes associated with its GPCR, thus resetting the signal transduction pathway. The GPCR-mediated signal transduction pathway involves the binding of a ligand by GPCR, formation of an activated G protein by replacing GDP with GTP, dissociation of the GTP-bound G protein from GPCR and association with an inactivated enzyme, phosphorylation of the inactivated enzyme, a cellular response, inactivation of the enzyme by dephosphorylation, and dissociation of the GDP-bound G protein from the inactivated protein and association with GPCR.